Search and recommendation systems are at the center of information flows in today's digital platforms, helping us manage information overload and quickly find what we're looking for, and also ensuring that the messages and documents and other content that we care about reaches us as well. Today we're seeing search and recommendation transformed, being used to connect us with more information, services, and products, both critical and quotidian, than ever before. Bootstrapping new systems, avoiding critical biases, and generally ensuring that our algorithms work in such diverse scenarios is a significant challenge, certainly from a machine learning point of view. And together with this trend, we're also seeing greater awareness of the impacts and the consequences of the decisions these systems are making. In this panel, we're going to discuss the future of search and recommendation with the focus on how causal methods can help us with some of these biggest challenges. My name is Emre Kiciman. I'm a senior principal researcher at Microsoft Research and the moderator for this panel session. Joining me are Professor Dean Eckles, faculty at the Massachusetts Institute of Technology, a social scientist and statistician studying how interactive technologies affect human behavior, Dr. Eren Manavoglu, vice president of Bing Ads at Microsoft, Dr. Amit Sharma, senior researcher at Microsoft Research, where his research interests include causal machine learning and recommender systems, and Professor Yixin Wang, LSA Collegiate Fellow in Statistics at the University of Michigan, where her research interests include Bayesian statistics, machine learning, and causal inference. Our panelists together bring a broad spectrum of experience and perspectives on causality, from experimental methods to observational studies, and from classical causal inference approaches to newer machine learning-focused methods. I'd like to ask each of our panelists in turn, what does causality in search and recommendation systems mean for you? I'll start with you, Dean.
Yeah, I think the most direct and maybe narrow version of the question of what does causality mean in recommendation systems is when you show somebody something, what does it do to their behavior? And so a lot of times we're trying to show people things that are relevant to their interests. And so they might actually seek out those same things, products or music or search results on their own, even if we weren't recommending them to them. So it's often really important to distinguish between just immediate conversion events, like somebody clicking on something or playing a song, from whether that's actually incrementally causing them to buy or consume or explore things that they wouldn't have otherwise. So I think that's the most direct version of it. But really, because recommender systems play such a big role in commerce and society, often a lot of the questions we have now are much bigger than that, right? These are questions about how newsfeed ranking algorithms are changing people's political beliefs and perceptions of the other people around them. These are questions about how recommendation systems in music and other cultural activities affect how much attention is going to the head versus the long tail, and what that means for the whole economy for creators. So I think causal inference is really at the center of most of the questions we want to ask about recommender systems, search systems, and those questions are expanding from narrow ones that are like, is this recommender system improving things? Is this increasing sales? To broader questions about the economy, culture, and society.
Thank you, Dean. Eren, what does causality in search and recommendation mean for you?
I'll start by saying that it is a must for anyone who's working on search and advertising in particular. I'll focus on search piece a little bit more and actually, in fact, a little bit more on the advertising side since it's easier, that's my background, but also easier to give examples of why causality matters as much than perhaps in some other settings. As Dean already pointed out, like the questions about are we really affecting the user's behavior is really showing this particular ad or this particular result, resulting in the users to buy some things more than they would have otherwise. Does it really matter if we are doing this in a causally sound way or if correlations are just helping us predict better in this case? Well, the reality is, unless your models are causally sound, whatever you're doing in online advertising business, you have no reason to believe anything is fair to the advertisers, even if I forget about users. If you think about it, the simplest thing, click prediction is one of the simplest problems that any online advertising system has to worry about. This click prediction models or the expectations from these models typically is not just that it is going to produce some ranking and you're just going to show something or not, but how are you going to price that ad? Really, the main question we always ask is, if you're really thinking about how would a different ad perform were they shown instead of the one that we showed, this question is highly critical. It determines what the ad you're showing up will end up paying. So to me, causality is definitely a must in this space. Unless our models are causally sound, there is no reason for anyone to trust that we are doing the right thing for this economy, in search at least.
Thanks, Eren. And Amit, I'd like to ask you the same question as well.
Sure. I think Dean and Eren already gave good examples. For me, it was when I started in recommendation systems, it was about the question of treating the recommendation system itself as an intervention. So like you would have in economics, a policy intervention. Here we had a system that was presented to users, and it naturally begets the causal question of what is the impact of the system and what would have happened if it wasn't there, right? But more recently, I've also started to think of this question at a micro level for each item as well. Because as Dean was mentioning, right, these are not just items. Perhaps there's a musician behind them, or there are advertisers behind them, right? So now if you think of each item as an intervention, so now the recommender system's job is actually to choose between multiple interventions, right? And therefore you have to know what is the causal effect of each intervention. Because often if you're not careful, you might have a system that just looks at what's popular or what's rated more, right? And it may keep showing that over and over again. That's one of the simplest ways in which causality can come in and say, hey, there are other items, newer items, that may have a better effect on the person. So why not show them?
Thank you, Amit. Yixin, what does causality in search and recommendation mean for you in your work?
Yeah, so I think like Dean, Eren, and Amit has given a lot of very relevant examples on how we care about the causal effect of the recommender system and the recommendation as an intervention. And I think a popular one for the business purpose is we care about the click-through rate, or we care about what is the causal effect of these interventions on how much money we can make more out of this recommender system, or how much it benefit targeted advertising or benefit the business goal. I think on top of these intervention effects we care about, another thing we may care about is strategic actions or strategic interactions between human beings in the recommender system. In particular, we may care about intervention effects on content producers. Now that we see certain types of items are being recommended more through these recommender system, we also wanted to study these social impacts as to people may start to make these content that are more likely to be recommended more. And these are the other side of the interventions that I care a lot about. I think on top of that, the other side is we care about persistent relationships between the features we wanted and the outcome we wanted at a more abstract level. And we always recommender system, the human behavior, especially in long-term settings, they are evolving, and it's not a static system. We may train on our data set on one data point, have a good model. It may be causally sound and it works well. And we wanted to deploy it on a different data set. And in these cases, we really wanted to be causally sound so that this causal relationship is going to persist on different systems, on a different data set, on a different set of people who are operating on a slightly different set of characteristics.
Thanks, Yixin. So I wanted to ask a second question. Now I'll start with you, Amit. Thinking about the current trends in search and recommendation and some of the big problems that we've heard about in this first round, what do you think? What's your perspective on which of these is most important or promising to address with causal methods or insights?
Yeah, I think if I had to pick, I would pick the standard problem of recommendation, which is often framed as a relevance problem. But now if you think about the comments that all of us made, you can almost think of it as a causal inference problem where there's some observational data given to you about each of the recommendations. But what you really want to know, what if all these recommendations were randomized and shown to users, how would they react, right? So to me, I feel this is the biggest problem of how do we move away from just relevance metrics or similarity metrics to metrics about the causal effect of a recommendation. And how do we even reason about that? Because it's not like you have 10 items or you have 20 items, which is often the setting in more standard causal problems. And there, the ideal solution might be, hey, let's just run a randomized experiment over all 10 recommendations, or we can use bandit-like approaches. But I think the biggest challenge in recommendation systems is that you might have millions of items, and items are getting added every day, right? So even if you learn something nice about the million items today, a new item might come tomorrow, which may be very relevant for certain users. How do you learn that? How do you balance this exploration versus exploitation of the information you already have? And then related questions come up immediately on how are you being fair to the new item, or are you actually enabling people to discover new stuff, or is it more that people are just being shown what they might have anyways discovered?
Yeah, to jump in on that point of just the huge number of items, I think that's a big part of the challenge. So first, that maybe the classic recommendation engine cases we think of are things like major cultural products, movies and books, and there are new ones showing up all the time, but not that fast, right? But then when you think about something like your feed on Twitter or Facebook or TikTok, right? These are really often quite ephemeral items that are just coming into existence all the time. Many of them are not even visible to that many people. So the possible number of people that you could learn from about whether this is an item you should show to more people is quite small, right? If I post a photo that's only visible to 600 people, how do you learn whether that's something worth prioritizing because it's maybe a major life event that these people are interested in, or that it's not? And then even in cases where the set of items is more stable, often we care about sets of items. So some work led by my student Madhav Kumar has been looking at recommending bundles. And what's the effect of showing a bundle of products that we are offering, say, at a discount, right? So that results in a combinatorial explosion of items that you might recommend. And even in the absence of any discount, when you think about a recommendation slate, when you go to a home page and there's multiple items shown together, we often think about that as a bunch of separate interventions of items, but really it's a slate of items, and that's just a combinatorial explosion of intervention. So I do think that's one of the big challenges of a lot of recommendation systems and trying to do causal inference there, because frankly, so much of the causal inference literature has said, okay, we study a binary treatment versus control. We estimate average treatment effects, and the extension to many treatments is left as an exercise to the reader, kind of thing. So, but it turns out when you just have potentially more treatments than you will ever have data, right? Because this is combinatorial explosion. You're sort of in a different regime.
Do you think so? You just highlighted the diversity of tasks that are facing, recommender systems broadly, Dean. An open question to the panel: do you think that these are the same problem? Is there a core that's common, or are they just so different that they really require different ways of thinking for different domains?
I'll go ahead. I was just going to point out to Dean's point, this point about there being so much focus on binary questions. Did this happen or not? What was the effect of this one single thing? It's such a big difference, in my opinion. It may not require the fundamental, approach to be that different. However, you definitely need to think about the bigger problems and the usage of these methods in real settings. Otherwise, there is basically no way for you to develop something that would either scale to the space that we are talking about or be even usable. I mean, this is one of the big problems we face in search and recommender systems all the time. But especially if you think about the whole page that you see today, if you go to any search engine. You're not just going to see one type of recommendation. You're not going to see just one type of result. There are 5, 6, 7 different entities that could appear on that page, and each one of them actually has like n different things that they are trying to show to you. How do you actually reason about this whole space itself is definitely a different type of problem, if for nothing else, for scale part of it, in terms of feasibility part of it, it is going to be different. And I do think more focus on this aspect is definitely warranted in this case.
Yeah, I was just going to add, I do agree. I think these are very different problems. For example, recommending in a bookstore versus on a search page. But I'd like to just make a connection to classification in machine learning, where often you're classifying very different kinds of problems. Sometimes it's multi-class, sometimes it's for making decisions. But somehow they're accepted metrics about how you would do well in that case. And also, I think more and more people are coming up with out-of-distribution metrics for classification. And perhaps that may be one way where we have some broader understanding of what's good for a recommendation system in terms of some metrics that we can capture. But the actuality of how you do that, I think, yeah, I do agree. I think that would differ very, very much across different settings.
Well, and the stakeholders that are involved are often quite different, and how much we think we should be concerned for those different stakeholders may vary a lot, both from the case where consumers are often producers, like in social media, to the cases where actually the producers are giant firms, and we may be less concerned with that somehow they're not getting the attention they deserve. But we might wonder whether they're behaving potentially in adversarial ways and trying to game our recommendation systems. So I think that's something that Yixin brought up and is really relevant. Is that it's not just that we should have the consumer only in mind. Often this is part of a larger ecosystem, right? That when you're deciding whether to show something to somebody in social media, it's not just about them. It's about the person who produced that, and it's about downstream consequences. If you show me something and I comment on it, that might provide value to the person who posted it and also to people who see it downstream and further engage in conversation and connection around it. Or it may be that my toxic comment sets off a cascade of really negative outcomes for the poster and for the public conversation. So there's like many stakeholders, and how we weight the outcomes for each of them may be really different a lot across a lot of these problems. And in some cases, it's really just kind of a insurmountable problem to solve exactly. We just kind of maybe try to keep afloat with a lot of it.
Yixin, what's your perspective on this diversity of domains and requirements from the machine learning and statistics and causal inference perspective?
Yeah, I really like the perspective brought up just now on like now we're facing a problem where we have millions of possible treatments. How do we handle that? And I wanted to add on a connection to the representation learning task in just vanilla machine learning, where we do representation learning on images and tasks and working with pixels and like lots of pixels. And if we shoehorn that image classification problem into a causal problem, in essence, we are trying to determine what is the causal effect of some functions of the pixel on the labels of the image, right? Like if we hope that the representation, which is the function of these pixels, will capture some like meaningful features of my image, and we're trying to learn that mapping, how do these features is causally affecting the outcome, which is the label here. So I think a parallel problem may be worth considering in the recommender system, even though I haven't seen any work really doing that. But I think this is a great opportunity for us to think about representation learning with all kinds of different treatments. Can we reduce the dimensionality of this huge space of treatments down to certain features? And can we learn these features as we did with images and text? Yeah.
Following up on this, so these are some pretty, I think, grand challenges. I'm curious, I'll start with the industrial perspective, Eren. What do you think are some of the main, either kind of logistical or more kind of systematic blockers to making progress on these challenges? I'm thinking like, do we need more education about these methods, tooling, data sets? better benchmarks as the world changes? What do you think is going to enable the next breakthrough?
All of the above, but all kidding aside, I do think education is definitely part of it in the sense that, luckily it's getting better, but machine learning without having causal inference perspective, I think this is a big miss if there are still, programs out there where causal inference is not part of machine learning, requirements, basically. To me, it would be a big miss. And I do see this in the candidates, that this isn't always there. So that's number one, and I do think it's a big problem. Number two, I will highlight is data sets and this notion of what truth means if the type of questions we are trying to answer require multiple parties, like the example Dean was giving, or Yixin was also hinting at before. If you have multiple parties that are interacting with each other, and what one does actually changes what the other one does, and that changes what this itself is not very well defined right now. I do think we need more focus and effort on this part alone. And Emre, from our collaborations that we are kind of attacking this one problem at a time. And the main question about, can we actually, generalize from what we are learning in one domain with this one setup? Like, how much of it can be really generalized is a question that we still do not have a clear idea on. So my focus would be that. But then again, a third thing I will add is along the same lines, defining metrics is also a place where we are missing, right? Like, I'm not an expert when it comes to fairness, but I have interest in this area. As far as I know, we don't have a good definition of even what fair means in the spaces that we are talking about. We do have impossibility results that I'm aware of, but no good, or not yet a consensus on what definitions work and what should be applied when.
Dean, what do you see from where you sit as some of the key blockers?
Well, I guess I'm happy to second the point that some process of interference or spillovers or moving from one equilibrium to another because of interventions in a marketplace or a network, that's a big challenge and something I've really enjoyed working on. And that, again, in a lot of ways, results in something that looks like a combinatorial explosion of treatments, right? Instead of thinking about, we have the new recommender system for this person or not, now we're thinking, wait, isn't that person's outcome affected by what recommender systems other people have? And so, again, I'm saying now we have to parameterize their outcome, their potential outcomes, not just by their own treatment, but by other people's treatments. And so that can make things really difficult. So I think that's a very exciting area. One of the approaches that has characterized the causal inference community, especially in statistics and econometrics, is to try to take a very non-parametric, reduced form and assumption-free approach to problems. And that can take you a long ways, but also I think at some point you just fundamentally run up against a wall there where you need some model of how units are interacting to maybe reach an equilibrium. You need some model of how each of these items are not just totally unique items, but could be featurized in some way, as Yixin was describing, right? So that there could be some representation of them, so we could borrow information across items. So that's going to be one of the interesting things, I think, from both the education and interdisciplinary community aspect of this, is how people are going to start to embrace approaches to causal inference that can't always be cashed out in terms of non-parametric, almost assumption-free approaches, but require some sort of modeling structure.
Yixin, with what are you seeing in your research agenda? Do you have a perspective on the blockers for progress on some of the problems that you care about in this space?
Yeah, I wanted second what Eren and Dean both said. One is, how do we define success in this space of having an effective recommender system? What is the outcome? It needs to be defined. The second thing is, what is the treatment, or how do we featureize the treatment? Is also to be defined. And I think on top of that, I think there are a lot of important causal inference ideas, in particular in terms of uncertainty quantification. Not just looking at sample uncertainty, but also looking at identification uncertainty in the sense that there's a limit of the data, how much the data can tell us, and really acknowledge that limitations when we analyze observational data and develop automatic, not necessarily automatic, but like easy to use tools so that like users or just people who are interested in recommender system can just take and use. And it's not just like pulling standard sensitivity analysis tools, but also thinking carefully about what kind of sensitivity assumption or unconfoundedness assumption, whatever, or like standard causal assumptions will make sense in the context of recommender system. And how can we design tools and software to just streamline this process of like a workflow for doing causal inference on recommender systems.
So I also just want to second the idea that coming up with good outcomes and metrics is really key. And it seems like some of the like classical recommender system cases, maybe it's easy. It's like, oh, do you add the product to the cart, right? And then we can do a causal counterfactual version of that. How much more likely are you to add the outcome, the product to the cart if you're treated? But even that starts to not be enough, even just in a bare commerce perspective. It's like, well, maybe we need to wait a while to figure out whether this person keeps the item or they return it. That could be key for profitability, right? And then in other settings, we also care about, longer term outcomes. So, Netflix doesn't care just about whether you start streaming this program or whether you finish it. But in the long run, they're hoping that this is helping to drive customer satisfaction and retention. But that's pretty hard to move and pretty far in the future. And then, in the context of a lot of the more societal outcomes that we've discussed a little bit, those things are often really hard to measure and over the longer term and noisier. And so one of the areas I'm excited about is surrogacy modeling, learning, shorter run, more precisely estimable metrics that capture a lot of how the things we're doing affect bigger picture, longer term outcomes. But there's a lot of things that can go wrong in that. And there's a lot of still just kind of human in the loop intuitions about what make good metrics, what motivate the teams that have to do a lot of the actual hard work of improving the recommender systems. Those are all questions that still are like kind of left up to managers and that people don't really have clear guidance necessarily from the technical side yet. So,
Amit, what do you think would help with some of these problems? I'm thinking particularly, I guess, of your work on perhaps on sensitivity analyses and in this area, but maybe more broadly.
Yeah, I think one of the things that's from the technical and academic side that often hurts progress is the absence of benchmarks. So right now, the typical way, if you want to build a recommendation algorithm, you'd have a benchmark which has some items shown to a user from some algorithm, and then you split it into two, and the test set also has some items shown from the same algorithm, right? So now if you create some really new magic algorithm that predicts something good for users, but was not predicted by the old algorithm, you'd be at a loss on how to measure the impact, right? Most often people would just discard that, and you just match how many items actually match what's in your test data set, which is not a reference for what is good, because as I think all of us have now mentioned, that's just observational data. That was just what's happening on the system. And this is kind of a fundamental problem, because unless you can measure or have a measure of how good something is, and especially talking about people outside the industry, right? Because there you don't have access to the system to randomize. I strongly feel, I think we need some ways of creating benchmarks so that it is possible for you at least to evaluate how your model would have done if it was deployed, right? And I think that then comes to these questions of, like Dean was saying, do you build a counterfactual model? Is it possible, if it's a simple, let's say, e-commerce system, is it even possible for us to construct some counterfactual model of the world that's not known to this person developing the algorithm? And could that be used? Could we think of sensitivity analysis of different kinds of scenarios that could play out. I feel one thing that's required, but it's actually a bit hard to popularize, is the notion of not knowing, right? So is this recommendation good? I don't know, right? And I may give you a probabilistic metric of probably yes. Let's look over for some more and understand that. But I think that's a bit hard to popularize. It's still nicer or more convenient to think of, hey, you get 1 precision for this, you get 0 precision for that. So that is a challenge, I think, both from developing those benchmarks, but then also popularizing those benchmarks among the community, because they might be so different.
I think we've reviewed a set of really fascinating challenges. I want to call out a couple of the more, I think, critical, open, very open, like long-term challenges here around, I think, Dean, you mentioned the effect of long-term metrics and thinking about the impacts of system changes, new policies, even exogenous changes, perhaps, or the accounting for at least the effect of exogenous changes. And we also talked about I think what we call like responsible AI, questions of fairness and bias, the impact of privacy and security concerns, autonomy, transparency in these systems as well. What I guess as we are ending right now with our last couple of minutes, I wonder whether you have just a sentence or two about what you would recommend for people who are looking to enter into this space. And I'll ask, I guess, perhaps Eren to start.
So, yeah, what was going through my mind after, hearing this conversation, and of course, thinking about these problems day in and day out, just virtue of my work, one of the big things clearly is if we want to answer these questions about what is the long-term effect of X or Y, even in the simplest of scenarios, because nothing ever really stays constant, and because actually if you're really trying to change or influence a user's behavior, it takes time, that this long-term being a really long-term period, if we are talking about months, for instance, and other things not, staying constant at the same time, we have to figure out, good ways of utilizing both observational and experimentation data. And this is something that obviously, there's a lot of work on, and I'm quite excited to actually see the progress on this front. But, really, there is no way to just answer these questions by designing a specific experiment for each one of these things that you want to measure. This piece is, to me, the most, important part for us in practice, at least, to get right. Like, I can't get away from using observational data, however smart I might be in coming up with the new way of, randomizing things. It's just not feasible to get to the combinatorial, possibilities we are talking about here. As I said, as we incorporate more components in this thing, it's just not going to be feasible. The other part of it is that as long as we are talking about systems that have human in the loop, which is the case for search and recommendations, privacy is definitely going to make things more interesting, but definitely challenging. And this is a reality that we need to figure out how to live with, and an area that requires more attention, in my opinion.
I think maybe it's characteristic of the tech industry that you said we got to worry about the long term, which could be multiple months, right? Which in many areas is obviously quite fast paced. But I think I agree that somehow using observational data is key in a lot of cases. But also one of the things that this non-stationarity, that the constantly changing nature of things suggests to me is just, never stop exploring. Constantly be doing some small amount of experimentation. And so if you wanted to start somehow and you're saying, I've been doing recommender systems in some way, but I haven't thought about it from a causal perspective, the first thing you can do is add randomness. And this can allow you to at least start to answer a lot of different questions. Now maybe you really should use observational data. Actually, there's some proofs that at least if you have a high dimensional model, it's inadmissible not to shrink towards the observational data, right? But a great starting point is to start exploring, to start adding some randomness to those rankings, and you could learn a lot from that.
Yeah, and I think just to add in terms of a person starting, these are concepts that I think require us talking to people from other fields, right? So if you're thinking of exploration versus exploitation, there's a lot of literature in reinforcement learning that can help optimize that. Then if you're thinking of multi-sided markets, of course, economics, when people have thought about those kind of questions for a long time. And I think someone especially starting, it's good to start with different perspectives. So not just look at the latest recommendation algorithm, but think about or read what economists are saying about it, what causal inference says about treatments, and then also things like reinforcement learning, how we are thinking of doing interventions optimally. Maybe some confluence of that will help us decide some metrics or some objectives for these tasks.
And as we're running out of time right now, Yixin, you get the last word.
Oh, yeah. Just to add to all of us, what we all have said, we wanted the right metrics, trying to talk to other fields to figure out what is the right metric. And I also wanted to highlight the point Amit made, which is we wanted to have people to become more comfortable with saying things that they don't know about something. We acknowledge the limit that what the data can tell us about, especially these causal questions. And importantly, not all causal questions can be answered using observational data. And that's a very important point for users of recommender systems and using observational data to really get comfortable with, there's a limit to what we can do with the data.
I'd like to thank all our panelists. Thank you for your time and for the great discussion. And I'd like to thank the audience. Thank you for listening.